Well, hello guys, here Mr. G with another video for the grade 10s. They're writing the question paper very soon, so we're going to be answering some questions. This one is going to be question 4 from the June examination 2013. And before we answer the question, subscribe for the channel so you can get all the notification. The question says the picture below is of a cloud to ground lightning discharge in a field. Sound waves are generated by the above thunderstorm. What type of wave is a sound wave? Now, you need to know that sound waves are longitudinal waves. Very simple. All you have to do is to remember that sound waves are examples of longitudinal wave. Okay? Now, question 4.2. The sound from the thunderstorm moves through different medias. Explain the relationship between speed of sound and the properties of the following media through which it moves. Now, to speak about what does affect the sound, the speed of sound, we're going to write here. Now, the first factor that is going to change or affect the speed of sound is going to be the phase of the substance in which sound is moving. The phase is the first factor. Now, what we need to know about the phase of the medium that is going to affect the speed of sound. All right, so what do we have to say? We have to say that the phase affects the speed of sound, and that sound, remember we're speaking about sounds, that is why I'm not going to rewrite the sound, travels faster in solid. It will travel faster in solid than liquid and slowest in gases. This is very, very important because you can get confused there. The other factor that is going to be affecting the speed of sound is the temperature. So the temperature is the other factor that will affect the speed of sound here. You need to know that sounds travel faster at higher temperature. Now this one happens when the substance have the same state of phase. Let's write phase, which we wrote before. So same phase. At the same phase, for instance A, if we're speaking about A, the sound will travel faster at warm A than at cold A. Guys, and these are the two factors that is going to affect sound in this specific question. Okay, so that one is question 4.2 is quite simple. Question 4.3. The thundering sound observed by the listener is very loud with a low pitch. State to what wave property does each of the following relates loudness and pitch. Now, what we need to know here first, loudness of sound is related to the amplitude. Loudness of sound is related to amplitude. That is the first important thing there. And pitch of sound, which is there, is related to frequency. It's related to frequency. Now the question 4.3.2 say explain why the listener observed the sound as loud and the pitch as low using the wave property state in question 4.3.1. Guys, loud sound, if the sound is loud, it means that the amplitude is big. That means that the amplitude is big. Quite simple. And if the pitch is low, as they say that the question saying that means that the frequency is low. Because of the relation between frequency and pitch and amplitude and loudness. So this is very, very simple. Question 4.4, which is the last question of this question 4, would you consider the thundering sound as ultrasound? Give a reason for your answer. So in this case, what we have to say, no. The answer is no. Why is not a ultrasound? Because ultrasound cannot be heard by the human ear. However, the person that was there could hear the thunder. So guys, a thunder is not an ultrasound. This is question 4. I hope it helped. If it helped, thumb up, subscribe for the channel. I'll see you next time. Mr. G here.